Hi there, future Ps. This is Wasim Asgar. I'm a licensed professional engineer in the US and Canada. I've authored several books on the topic of FE electrical and PE power exam preparation, and I also run popular exam preparation programs for FE electrical and PE power exams. So without further ado, let us dive into the content. Engineering economics is an extremely important topic. It is a standalone section in FE electrical and computer exam specification. Used to be a line item on the PE power exam specification up until 1st of October 2025. It has since been removed directly, but indirectly, even on the PE power exam, the core concepts related to engineering economics can still show up in demand calculations and energy management. From a real world engineering standpoint, whenever we are choosing different options, so let's say we are thinking about retrofitting an existing equipment, refurbishing it, or purchasing a new one, transformer upgrade versus capacitor bank versus demand reduction, and so on and so forth, you have to have some fundamental level of understanding of time value of money, of interest rate, on the cost benefit analysis, and things like that, the trade-offs. So what is the initial cost? If I actually spend upfront, will it reduce my operating cost? An example that comes to my mind right away is purchasing a transformer that has copper winding versus aluminum winding. You guys know the difference between a transformer that has copper winding versus aluminum winding? What is the key difference between the two transformers? The construction is different. One is based on copper, the other one is on aluminum. From a capital expense standpoint and upfront cost, the ticket price, which one is more expensive, copper or aluminum? Which material is more expensive? Copper. Copper is more expensive, which means that the copper transformer, assuming everything else is the same, the rating of the transformer, MVA rating, and everything is the same, the voltage levels, and so on, all the accessories that you're buying with the transformer, dissolved gas analyzers, sudden pressure relays, and everything are identical. This is going to be more expensive compared to an aluminum. I've got this small request for you. 77% of you watching right now are not subscribed to the channel. That's a massive number. If this video is helping you out in any shape, way, or form, please do me a quick favor. Please hit the subscribe button and ring the bell. That way you will not miss out on any content that we've got planned, and it really supports the channel. But what about the operating cost? The operating cost, if we operate with the regular duty cycles, right? Which one is going to be more expensive, copper or aluminum? Aluminum. Reason? Because of the I square R losses. Reason? Because of your core losses, copper losses. Because the no load and full load losses of a aluminum transformer are going to be higher. So how do you make sense of this? There are actually spreadsheets calculations that, as a technical engineer, power systems engineer, when you make a recommendation to a project manager as to why the project manager should spend extra cost on CapEx by purchasing copper transformer versus aluminum, you are calling engineering economics into action. Time value of money. So the dollar that we have today in our pocket is not equal to the dollar that is in the future. Is it going to increase in value or decrease in value? What is the general tendency? The correct answer is it depends, right? It can either increase or decrease. But what does it depend on? Engineering economics helps us answer that question. The value of the dollar is going to depend on interest rate / inflation. So inflation typically tends to increase or decrease. Typically always goes up unless you are in a deep recessionary period where the price of articles, goods starts falling, right? Then that's deflation. But generally speaking, even the central banks like the Fed tries to maintain it around 2 to 3%, closer to 2%. In fact, that is their mandated goal, to keep inflation around 2%, because then it is an indication that the economy is running not too hot and not too cold, just about right. Okay. And that brings into play present worth, future worth, annual worth, and so on and so forth. Common applications in power engineering. So whenever you're doing any type of cost estimation, whenever you are trying to procure major items and doing CapEx, OpEx calculations, engineering economics is always at the background. And more directly, more explicitly, in the context of the FE and P exam, this is an opportunity for you to actually encounter more or less a plug and chug type of knowledge area where you can score relatively easy points, but you still need to understand the structure of the questions. They are typically structured. You will have interest rate given to you, probably. You will have some dollar figures given to you. right? And the way the questions are asked are a little bit predictable. So if somebody's asking for the future value given the present value, you'll have to just zone into some of the key areas, and that will basically allow you to unlock the problem. And time efficient, typically within 3 minutes for FE electrical, which really is our target, because on the FE electrical and computer exam, we have how many questions, guys? We have 110 questions on FE electrical and computer exam. And we are given only 5 hours and 20 minutes. And that translates into 3 minutes per question. So Eng Econ questions typically tend to be, if you look at the FE electrical sample exam, tend to be within the 3-minute time range. So it's a good investment of your time. And these are easy points to score if the fundamentals are clear. So that's why engineering economics is really important from the standpoint of real world engineering decisions, from the standpoint of cost benefit trade-offs that you may have to do at work, and even in the decision-making process. For example, if you're thinking of purchasing a car, right, you would have to take into account whether it's worth buying a new car, typically it's not, or a used car. If so, should I go about leasing it, financing it, or paying for cash? You're going to look at the depreciation curve of different types of cars. Typically the luxurious brands and German cars and a lot of more expensive, fancier cars, they depreciate very aggressively in the first couple of years. So maybe the sweet spot is to basically let somebody else experience that depreciation, and then you basically pick it up. EV versus ICE, right? So EVs typically don't hold their value as much and depreciate quickly. So if you are not after the fanciest and the bells and the whistles that are being offered in the latest and the greatest model, and are looking for something that's functional, and your goal is fuel efficiency and whatnot. So all of these things, I mean, it does give you the tools to be able to analyze. In fact, in the FE electrical and computer exam, we have two types of depreciation. We have the MACRS depreciation and we have the straight line depreciation. Straight line depreciation is not used for taxation purposes, easy to understand, and kind of helps you with the back of the envelope calculation. But from IRS standpoint, so taxation standpoint, the depreciation we use is MACRS. So you basically are supposed to know that for Eng Econ. And time value of money, everybody understands this concept, but it gives you that additional foundation and knowledge and the technical depth to be able to articulate it, explain it, and understand it properly when you are trying to make sense of interest rate inflation and their interplay. And as power systems engineers on major and minor projects, capital projects, maintenance projects, you are always dealing with the cost, right? Safety, cost, schedule. These are the three major pillars that you have to optimize on. So safety, non-compromisable typically, right? I mean, if you can have a minimal viable product, even then you have to make sure that safety is not compromised. So that is always a given. And then you have to choose between the cost and the schedule. And from an FE exam and the P exam standpoint, the P exam is 80 questions, 8 hours, 6 minutes per question. It's not really a race against time, but still, I mean, there can be multi-layered problems that can still push you up to 6 minutes per question. So this is the reason why we should pay attention to engineering economics, and this is the reason why Eng Econ is important. If you're new to this channel, please consider subscribing. On a weekly basis, I'm creating content for FE electrical and P power exam preparation. I also discuss topics related to electrical engineering with a focus on power systems engineering. If you'd like to learn more about my FE electrical and P power exam preparation programs, please visit my website, studyforfe.com.